going to go through the installation and usage of rotor control daemon for an infrared rotator controller. The code can be found on GitHub, and there's a substantial README there that you can go through and see various information around the installation and usage. Hamlib rotor control D for rotating controls written in Python is a implementation of the original Hamlib Rotctldpy program. It listens on a TCP/IP port and accepts standard rot control commands, so it should be able to be integrated with any standard amateur radio software that uses Hamlib to control rotators. The particular implementation that I've used is using the Sharman AR 600 XL rotator and a Flirc USB dongle that can send and transmit infrared commands to the control box to operate the rotator. The Sharman rotator you can buy online from most amateur radio stores, and consists of the actual rotator unit that sits on the mast and a control box and a remote that can accept infrared commands that sits inside your shack. It's got 12 programmable buttons, and so you can program the 4 cardinal directions as well as 2 intercardinal directions as well, so something like north, north-northeast, east-northeast and east, etc. Once you've got that all set up, you can then install the software that I've written here, and within the software you get a send IR script either in Windows or Linux or Mac, which has the infrared codes for the Flirc USB dongle installed and created already. The process of installation is relatively simple. The hardest bit's getting the Flirc USB dongle to work. You can, of course, replace the Flirc USB dongle with any other infrared transmitting hardware, but you would need to update that send IR script to take into account new command line commands that you'd execute to trigger a rotation. You can see that the setup that I'm going to do is I've got a little Raspberry Pi that has the dongle installed. I'm going to show you how to install the Flirc binaries and also the code that I've written to use the Flirc to transmit the infrared command. You can access the software remotely via your home network. So you could either use the web GUI, which I'm going to show you how to use, or indeed something like Gpredict. There's an example of the web GUI. With the beauty of this the way I've implemented it is by using the send IR script, you can integrate with other third-party tools as well that don't necessarily use the Hamlib libraries. So for example, I've created a small compass that I've installed in my Home Assistant, which allows me to select any of the directions and that will trigger a rotation. So the Flirc USB dongle is available online as well. You can go to their website and download the relevant software for your operating system. It works on Windows, Mac, or Linux. So you've got those various options down there to run and install the software. I'm going to go through the process now. So I've got all the commands already sorted out, so we don't need to waste any time in the video. But here we go. So I'm going to log into my Raspberry Pi with the -x parameter. Now I'm running headless, so I don't have a Windows system installed on the Raspberry Pi. So I'm going to use the -x parameter to start a Windows start the Flirc USB software with a window using -x Windows system. So I'm logged in with -x. To install the software on the Raspberry Pi, you can just run this this curl command that downloads the installer, and we'll run it. So you can just run that, and it's going to go away, and it's going to get the various libraries, etc., that Flirc needs to use to run. It's going to update all the stuff via the normal Raspberry Pi package management system. It's asking whether I want to install the Flirc utilities, which I do. So I'm going to press enter there, and it's done. So that will mean that you've got some software installed on your system, including the command line utilities and also the Flirc USB software, which I'm going to run now. Unfortunately, you need to run a firmware update, and the only way to do that is by starting the software, which is installed in /bin/Flirc with a capital F. So if I run that, it will launch the Flirc software. You can see here I've already updated my firmware, so I don't need to do it again. You can see the firmware version down here. I'm running on version 4.10.3. If you want to update the firmware, you simply go to File, Upgrade Firmware. Unfortunately, the firmware that I've got means that it's not going to do it automatically, but the out-of-the-box firmware will automatically download and install a later version of the firmware for you. So once that's done, you can exit the window. We don't need to use that anymore. You can see whether or not the device is connected. Obviously, the device will need to be connected before you upgrade the firmware on it. And so if it's not connected, you need to make sure it's plugged in and ready to go, and detected by the Flirc software. So we've got the Flirc USB software installed. We've got it plugged into the Raspberry Pi, and we've upgraded the firmware. So now I'm going to download and install my rotctld software written in Python. I'm just going to do it in a temporary directory. I've actually got it already installed on this Raspberry Pi, but for the purposes of the demo, I'll just quickly run through the install process. So I'm going to do it in a temporary directory. So I'm going to make a temporary directory and move into it. And then I'm going to create a Python virtual environment. You don't necessarily need to do this step, but I'm doing it just to show you that it's all self-contained. I haven't got any additional libraries running on the Raspberry Pi that you need to worry about. So what this is doing is it's creating a virtual Python environment with no libraries installed. It's an out-of-the-box Python install essentially, and it's installed in the /home/pi/temp directory. So from here, I'm going to go away and I'm going to download the software. I'm using git because it's on the Raspberry Pi already. I'm just going to run this git command, which is going to go away and download the software from my GitHub repository. Out of interest, if you don't want to use Git, you can go to the releases here, get the latest version of the release, and download the installer or the source code in a zip file or a tar.gz file, and just extract it on your operating system in the right place. So we've got the software downloaded. I'm just going to go into the directory that was created during that git command process, which is a new directory called rotctldpy. And from here I'm going to install some libraries that are required to run the Python scripts. So that it's all come down in this requirements.txt file. I'm using the Python virtual environment that I've just installed in the level above, and using the Python library installer pip. So it's going to go away and it's going to read the requirements from requirements.txt and install the required libraries. From here, we've got, if I look at the directory, we've got the source code that's been downloaded, and we've got a couple of bat scripts or shell scripts, including a run.sh or a run.bat. You can simply use that if you're using your default Python environment. If I just cat the run.sh, you can see it's running Python and then the script rotator.py. It's got some various parameters and that's it really. So we can run the script. Again, I'm using the Python virtual environment that's just been created. I'm just going to run it with a -h parameter just to view the help. It's bin/python, sorry, my command wasn't right. So if you run it with the -h command, it gives you a little help dialog. We've got various options, including the listen port, which is a web server port that will come to that hosts the GUI, and also some other ways to interface with the software. We've got the -g command, which will automatically connect the web GUI to the server that's built into the Python script. There's a warning here. You know, obviously you don't want to be controlling your rotator with multiple source software like the web GUI or Gpredict, so you only use one at a time. I tend not to start with -g. We can always connect to it later if we want to, and I'll show you how in a bit. And we've got a -s and -p parameters for the host and port, and a -d for to enable some debug information if you want. The host and port, I'm running my Raspberry Pi headless with both a wired and wireless network connection. So you can see the command I'm going to use above. I'm going to use --host 0.0.0.0, which binds to both NICs. If I'm running on Windows, I would use localhost. But if I go away and run that command that I've got here, obviously I want to fix the bin problem. This should start up the server. Actually, I've got it actually running somewhere else. I need to stop it very quickly. Go back to my other screen. So hopefully it's stopped on the other terminal, and you can see I'm starting it up. It doesn't look like it's stopped properly, so I'm going to stop it here again. for it to close its ports in the background, but it should start up correctly this time. And it has. So we can see some stuff coming out through the script here. We've got this this info message at the top. It initializes and starts by pointing your rotator to your initial direction. In this case, it's north. It starts up the web server. It's got some various other messages, including the fact that we've got a web server available. So we've got the GUI up and running. We can connect. Sorry, we've got the server up and running. We can connect to it, the web server, by going to the IP address of the host. You can see this is the web GUI interface to the software. You can see it's not connected. There's two parts to the software. There's the server, which is actually the stuff that the amateur radio software will connect to, like Gpredict, and there's this web GUI that allows you to test it. You can load this on a mobile phone, for example, and go and up on your roof and press the buttons here to control the rotator. So if I just quickly connect to the server by clicking the connect button, you can see it will connect. And it's got our current position and set point. So the current position is north 0, 0. It's got a fixed elevation. It doesn't rotate in elevation. It goes around azimuth. And it's currently, we're not sending it any instructions, so we haven't set any instructions. If I wanted to, I could move the rotator 30 degrees by clicking this button here. You can see that we have set a set point of 30 degrees, and the rotator is currently rotating, and it's just finished and it's got to 30 degrees. I can send it home at any time by pressing the home button, so back to north, which was the original position when the software started. There's also an initialize function here, although obviously you don't want to initialize because it goes all the way through the whole cycle and back again, but sometimes you need to reinitialize the motor just to make sure that's all set up correctly. But again, you can push any of the buttons here, and the command has been sent to the server. In this case, I'm rotating around 150 degrees, which I think is 30, 60, 90. It's going to be south-southwest, and so it's turning it around to the rotator around at the moment, and it's still going, and it's going to finally arrive at its destination in a moment. Now, as I said, this is not much use if you're wanting to control your antenna with software, but it's a nice way to test. And as I said, you should only have one piece of software connected to the server at any one time. You don't want to be confusing it by sending it multiple commands. So I'm going to disconnect the web GUI from the server itself, and you can see that we've got this not connected sign here now as well. So let's set up Gpredict. So I have Gpredict running on a virtual machine, a Windows virtual machine. It's nicer to see and use it on this machine because of the video and X Windows system, but you could run it all on your Mac or indeed on the Raspberry Pi if you wanted to as well. We can see that we've got a satellite coming up in a few minutes time. We've got nothing live at the moment. Let's see if we've got anything live in these other windows. We've got one here. We've got FO29. So FO29 is going to leave us in 5 minutes time. That's fine. So we can look at this FO29, and we can actually, we'll go to the first step first, but to set up the rotator and Gpredict, we go to interfaces in the settings, and we select rotators. I've got this one already set up. You can see here that we've got, it's called rotctldpy. It's got the host name of the server that, or the Raspberry Pi that I've installed the software on, and it's got the port 65432, which was the port that we used on the command line to start up the software. The AZ type is 0180-360, which is I think the default, and I've set the min and max elevation to be 15 degrees, which is what my software is returning back to Gpredict, so it's not going to complain or anything like that. So it's just all set up relatively easy, nice and easy to set up, and then we can go into antenna control. Now we've got this FO29 satellite that is orbiting at the moment, so you can see here it's currently in the north. It's going to be leaving us shortly. It's probably not a good example. Let's try and look at the RS44. This is a bit, it's leaving us as well. What about AO73? What's that doing? Yeah, this will do. Okay, so if we click the track button in Gpredict, you can see that the software is automatically tracking AO73's position. It's going to rise on the horizon in the east-southeast, and it's going to rise at about 12:52, which is in a few minutes' time. So in order to connect to the software, we select the device that we've set up in the settings, which is the rotctldpy system. I'm going to give it a cycle time of 10 seconds, so every 10 seconds the Gpredict is going to ask the rotator what its position is and ask it to move if it needs to. Because of the 12 directions on the rotator, I've got a 15-degree tolerance between the directions. So for example, if we are looking at the north, set at 0, and we've got the first setting, or button A, set to be 30 degrees, 15 degrees is the midway point, and so that's the point that Gpredict is going to ask the server to make a rotation to A from north or 0. So it's as simple as, after we've set those settings up, to press engage. You'll see it takes a second to connect to the server, and it's connected, and it's read the fact that we've got a 15-degree elevation and it's currently set to 150 degrees. You can see on the polar view there that the antenna moved to hit the target direction, or the set point of east-southeast. If I choose another satellite, let's just choose a random one, doesn't really matter which one, I don't think. We'll choose AO7. You can see that the set point is up, it's at the east, and so it's asked, Gpredict's asked the server to point the antenna to the east, and the antenna is now going to trigger and start moving towards the east, which is done. It was a very short hop, so let's choose some other satellite. Hopefully we've got a better example. This one here I think was better. So here we go. So our target or set point is going to be, it's going to be north-west, I think. You can see, yes it is, and you can see that the antenna is rotating around now towards the requested position. And it's going to make its way there. Once you're finished, obviously click engage to disengage, and we're all back to reset. So if we look at the output from Gpredict, from the software here, you can see that we've got several statements that have been printed out on the screen. You can see that this setting command here was Gpredict asking the rotator software to update the setting, and the rotator software recognized that button C was required, so it pressed button C using the Flirc software. Unfortunately, the Flirc software has this error message that's printed. It's actually a warning. It's working just absolutely fine, and I think the software is just a bit buggy with its logging levels. In the latest dev branch, that message won't be displayed. You can also see that because I disconnected at the end, the system's reset and waiting for another connection. I could just go away and use Gpredict again, or indeed connect using the web GUI. You can see that we've got the web GUI connected, and we can then reset back to home and press button L, which is the 0 degrees north button. So that's it. Have fun.